Okay, this is chapter 1, linear relations. And we're going to start on linear relations in tables and graphs 1.1. So we're just going to do a quick review on slope. And slope refers to the steepness of a line. So other words are sometimes used to refer to slope. And when talking about a roof, it can be called the pitch. On a road, it can be called the grade. Slope is a ratio of the change in the vertical distance over the change in the horizontal distance. And this can be written as slope equals, and this little symbol right here means change in. So the change in vertical distance over the change in horizontal distance, or you can also write it like this, and this is what you'll commonly see it as. And we use m to represent slope. And the change in the vertical distance is also called the rise, and the change in the horizontal distance is also called the run. So you can sum it all up by going slope, which is this m right here, equals rise over run. So just a typical drawing would look like this. So rise, run. And m is not here. A lot of people think that's m. That's not. Okay, that's the hypotenuse. Okay, example 1. It says calculate the slope of a line that has a rise of 15 and a run of 6. And B says if the same line is extended to a run of 9, what will be the total rise? So for B, you're going to need to find M first, which is the slope. And the reason for that is basically what they're saying in B is like, let's keep the same slope, just make the ramp or the triangle longer. Okay. So the first thing you would want to do is write down your formula, M equals rise over run. Okay, up on top, you can put the rise for 15 and the run underneath is 6. Now, in your calculator, if you have one of these, you can easily crunch the fraction with a little trick. And I'm okay with you guys using the trick. Um, so in your calculator, you can go 15 divided by 6, hit enter, and you'll get 2.5, which is our first answer right here. And I'm okay with you just using um, decimal answers for your slope. That's absolutely fine. This middle step is reducing the fraction by hand. So they found a common factor in 3 and divided 15 by 3 and 6 by 3 and brought it to 5 over 2. But the calculator trick is you hit the math button right here and you just press enter and it will turn it into a fraction. And there you go. But again, I think for most purposes that we're going to have in here, just put the decimal answer. Okay, and you can go to one decimal place is fine. Okay, now we have the slope. So you're going to use your equation here again. And what they're saying is, like the last thing that they, or the last ramp that we had was a 15 and a 6. So 15 up, 6 over. What they're saying is, what happens if we extend it to 9 using the exact same slope? See how it's kind of on the same angle? The question is, what is it here? But we're going to use our slope to figure that out. Okay, so all you're going to do is replace the symbols with the numbers that you have. So replace m with 2.5 and run with 9. And this is going back to junior high math here. So to get rise all by itself, you have to get rid of this 9 on the bottom here. And we always do the opposite. So if it says divide by 9, you multiply each side by 9. So the opposite, and make sure you do both sides. And what that does is crosses it out. And now you have rise equals 9 times 2.5. And the rise ends up being 22.5. So after all, that's what it was. Okay, so that's how we can use slope to figure out either a rise or a run. And yeah, so if you were given the rise, you could figure out the run and vice versa. Okay, build your skills. So this part of the course will be examples that I do with you. So you can just follow along. So what is the slope of a wheelchair ramp that has a rise of 3 feet and it runs 21? Okay, so you're going to write out your equation, which would be rise over run. And for us, the rise is 3 over a run of 21. If you want to do it as a fraction, would divide 3 by 3 and 21 by 3, and you end up with 1 over 7. Again, you can do the math frac trick in your calculator as well. Or you can just simply punch it in, 3 divided by 21, and you get 0.14. Okay, so there you go. So either is fine there. Okay, number 2. The slope of a staircase is 0.95. It rises 250 centimeters. What was the run? Okay, so 250 up. Question is, how far did it go out? We know the slope is 0.95. So we're going to put our unknowns into the equation. So 0.95. And then we got a rise of 250 over an unknown run. Okay, now this one's going to be a little bit trickier than before. It's going to be a 2-step because we got to get our unknown from underneath the fraction to up onto the other side and then one more step. So what we'll do is we will cross multiply, or kind of do what we did in the last question there, is just multiply both sides by run. And you don't have to show that part there if you don't want to. Okay, that's fine with me. And you got your run here. And just remember, if you just put a number in brackets like that, that's a better way to show multiplication instead of using the multiply symbol, the X, because the X can get confusing when we end up with variables. Okay, from here, if this is run times 0.95, we need to do the opposite and divide 0.95 on both sides. And we'll cross it out like that. And run will equal 250 divided by 0.95. Just punch that in the calculator. And we end up with 263 centimeters. If the information given was a decimal, like 250.7 centimeters, we would have went to one decimal place, but because they stop at the ones place, we will too. So 263 centimeters. And that's what the unknown ended up being. Okay. Marina is installing pipes, and the pipes must drop 4 centimeters for every 1.75 of horizontal distance. How much will the pipes drop in a horizontal distance of 250? Okay, so this is actually asking two things. Okay, so what they're saying is the pipes are going to go down 4 centimeters for every, I'll just draw that a little straighter, for every 1.75 over. Okay, so the slope is right here. I know it's kind of upside down, but that's fine. It's still the same thing. Okay. And why this question can be tricky is uh, the equation is rise over run. And in this question, it says it drops. So people think it's not rise, but it's still the same thing. Okay. Now what we got to watch out for is units. So 1.75 meters, if you're turning that into centimeters, okay, you have to move the decimal over twice. Okay, so meters to centimeters, you got to move it twice. So this is actually 175 centimeters. And if you need a review of that, you can come talk to me later. So our slope here, this is still the rise. I know it dropped, but that's fine. And a run of 175. And our slope will come out to okay. So 0.02228571429. Let's see what that is as a fraction. It's 4 over 175. So it's the same thing. So we'll just go to, in this case, we will go to 2 decimal place, or we'll go 3. And don't worry, in your assignments and stuff, I will tell you what to go to. Okay? So that's actually our first step, is getting the slope, because they're asking in the second part, okay, what if we wanted to go over 20 meters? How far down do we have to attach the pipe? So if that's the pipe right there, and you installed it up here, up in the top, how far down do you have to put it? Okay. So that's kind of the question. So there's our slope there. And we'll fill in the unknowns. So slope is 0.023. We don't know what our rise is, which is always the vertical. That could be another way of looking at it, is the rise is always the vertical. It's vertical over horizontal. Okay. So you could look at it this way too. Okay. Instead of rise over run. Now here, we're going to multiply both sides by 20. And again, you don't have to show that multiplication of 20 on the right-hand side. You can just jump right to here, cross multiply it. So 20 times 0.023. Now, if you have the decimal in your calculator, you can use the whole thing. It will end up being a more accurate answer. So you can just go second and then activate CANS for answer, this negative button, times 20. And it'll take this whole decimal or fraction and multiply it, which is more accurate. And our rise here is going to equal 0.46 meters. Or we could say, I'm just going to bump this over. 0.46 meters, or move the decimal twice, 46 centimeters. And there we go. Okay, the next part here. So the first part was kind of a review. So a graph, or so what we're going to look at is working with linear relations. And just so you understand what that means, linear means line. So we're going to be looking at slope on graphs, okay? A graph on a coordinate plane shows the relationship between the independent variable and the dependent. We will talk about those two in a second. A linear relation is a relationship that forms a straight line when the points are plotted on the graph. So no curves. The slope of a straight line is a constant, which just means the same. And you will see in the next example how those two line up. If a line passes through the origin, which is where the graph crosses in the middle, right there, 0, 0, it's called a direct linear relation. And you will have to know that definition. So, example 2. Kalinda babysits on weekends and charges $12.50 an hour. The following table of values shows her earnings based on the number of hours she babysits. So you can see the table. So if you work no hours, you make no money. Work 1 hour, $12.50. 2 hours, $25. 3, 37.50. And what you can notice here is that every jump is $12.50. It goes up $12.50. Okay. And that is going to end up being the slope of our line. So if you look at here, every hour of work that we do, it goes up by $12.50. Well, that is the slope. And you will see on the graph on the next page. Back to the independent and dependent variables, hours of work is the independent variable. And total earnings is your dependent. And the way to think about that is that time is going to move forward independently. It has no factor on your money or anything that you earn. And the way to think about dependent is that your total earnings depend on how many hours you work. And that's really the best way to think about it. Also, a little hint, independent is always time. If you ever see time as a variable, it's going to be an independent variable. So for A, we're going to answer a couple questions here. A, what is the independent variable and which is the dependent? And then we're going to use the data to draw a graph. And then should you connect the points on the graph? Why or why not? C, list 3 characteristics that you observe about the shape of the graph data. That's going to be, is it a straight line or a curved line? D, what is the slope of the graph and what does it represent? And how long will it take Kalinda to earn $150? So you can use your data to figure that out. So A, the independent variable is the time or hours of work. It will go on the x-axis. The earnings depend on the amount of time worked, so earnings is the dependent variable, and it will go on the y. And that's exactly what we talked about before. So you're always going to have time along the x-axis. And then you plot the points. So if we go back to this table here, we started at 0 and 0, right? 0 hours, 0 earnings. And then we go to 1 hour, and we went up to $12.50. Okay, so that's about $12.50 there. 2 hours, 25. Right? And then you plot all your earnings and hours worked. And then connect it with the line. And notice it starts at 0 and 0, so we would call this a direct linear relation because it starts directly at the beginning. Now, what it's saying here for B is, should you connect the points on the graph with a line? Why or why not? So even though the data is not completely continuous, and what they mean by that is there's no dots in between here, right? We put a dot on 0 and then a dot on 1, and we don't actually know if Kalinda worked, 2 hours or 2.5 hours or, 2 hours and 15 minutes. We don't know that. However, Kalinda likely earns part her hourly wage for partial hours of work, so you can still connect the dots on the graph. The points are joined to allow you to see the trend in the data, even though she is likely only paid to the nearest quarter hour. So it's fine. C, the shape of the graph data shows a straight line. Okay, so that indicates a linear relation. As soon as you see the word line, it's a linear relation. A line that passes through 0 and 0, that is a direct linear relation. And a line that slopes upward to the right. Okay, so back here on the table, every point was up 1250. That's what the positive represents. It went up 1250, and that's why our graph goes up to the right. We call this positive slope. Okay, and you can just tell by the numbers on the table on the previous page. To find the slope, so for D, what is the slope of the graph and what does it represent? Well, we kind of figured it out just by looking at it back here, right? And noticing it went up 1250. If you got a graph like this, you can easily use the equation as well. Okay, because if you take any 2 points, it doesn't really matter which two. Like I could take these two. There's my run, there's my rise. It's not going to matter which one you choose because a direct linear relation, a linear relation is going to have the same slope no matter what. So if you look at the red and blue triangle there, the slope is the same. And what you can do to make things easy for yourself when you do calculations, if it passes through 0 and 0, you should choose one of those as your points, right? Like you could actually just choose right here. And 0 and 0 makes the calculation very easy, and you will see in the example below here. So D, to find the slope, start by choosing any 2 points on the graph, such as 0, 0, and 450. So they chose 0 and 0, the beginning, and 4 hours and $50, which you can find right here, 450. Okay, and slope is calculated by dividing the change in vertical distance by the change in horizontal, and you can calculate this using the data points you choose. So here's the equation here, rise over run. And to get the rise, all they're saying is take your 2 points. So we chose 0 and 0 and 4 and 50. And you can consider these your beginnings, and these are your ends. 4 and 50 are your ends. And just make sure they match up. So you always put the final one or the end one first. So 50 minus 0. Okay, or the other way you can think about it is this is your ones, and these are your twos in the equation. So see how it goes y2 minus y1, x2 minus x1. You can do it that way if you like, or you can simply just measure. Like you can look on the graph and measure it, right? It goes over 50, or sorry, up 50 over 4. Rise over run. That might be the easier way to do it. Okay, and if you were to measure these, all you're doing is subtracting. So if I'm doing the blue one here, I'd go 5 minus 1 is 4 for a run of 4. That's all this is. So when you see these funky equations like this, all they're doing is subtracting to find the length. That's it. So you end up with rise over run and 12.5. So the slope is 12.5. Well, interestingly, we pointed that out before. That was your hourly wage. because it goes up by 1250. So the slope is your rate of change. How much do your numbers change? Okay, and back to the slope equation here, you can see why using 0 is the best, because you can just go 50 minus 0, 4 minus 0, and just use the numbers. Remember, you're just measuring the length and the height, right? Okay, this alternative solution, they just chose 1250 over 1 hour and divided and got the same answer. And that's because if we go back up here, all the triangles have the same slope. So they just did the green one, right? 1250 over, or sorry, 1 hour over, 1250 up. That's all they did. So you choose whatever one makes it easiest for you. And then E. It says, how long will it take Kalinda to earn 150? So you could go 150 divided by 1250 per hour and get 12 hours. Okay. So Kalinda will have to babysit for 12 hours to earn 150. Now, if you prefer the equation, right, if you just don't want to use the logic that you already have with your day-to-day jobs, you can put 1250 in for slope. Okay. And on the graph, the 150 goes on the top because that's the rise. How much money do you make? And on the bottom is the run, which is time. And if you get confused about where to put the 150 and the run, just go back to your graph and notice that the run, or the horizontal, is the time, and the rise is your income. And then you just line them up. And then from here, you can multiply run over like that. And then from here, divide both sides by 1250, and your run comes out to 12 hours.